Today we're learning about complex numbers. When you first learned how to count, those were called natural numbers. And then you learned the number 0, the absence of a quantity. Then you got to integers, where maybe before we could do 5 minus 3, but we couldn't do 3 minus 5. Integers are your positive and negative whole numbers. Then you have rational numbers, numbers that can be written as a ratio, like 0.3 repeating, or 1/3. And irrational numbers, like root 2, which is a non-repeating, never-ending decimal, or pi. All of these are real numbers, and real numbers are under the umbrella of complex numbers. Complex numbers also include imaginary numbers, numbers with I. Any complex number can be written in standard form, a plus bi, where a and b are coefficients, where the first part is the real number and the second part is the imaginary. A could be 0 and then you would have an imaginary number, or b could be 0 and then you would just have a real number. But every complex number can be written in this form. To add or subtract complex numbers is just like combining like terms. Combine the real parts, combine the imaginary parts, and write in standard form. Because there's a plus sign in between, we don't even need to write these with parentheses. The parentheses just show that 8 minus I is one complex number, and 5 plus 4i is one complex number. 8 and 5 are both real numbers, and they add to give you 13. Negative I plus 4i would be 3i. We write the real part before the imaginary. Because we have subtraction in between, we'll need to distribute that negative to each piece of this second complex number in order to write it without parentheses. Now combine the real parts, 7 minus 3 is 4, and combine the imaginary, 0. The standard form of this complex number has b equals 0 because there's no imaginary part. In part C, I have subtraction, so let's distribute so we can remove the parentheses. Combine the real parts and the imaginary parts to get 11 minus 2i. Multiplication with imaginary numbers is very similar to multiplication with binomials or variables, but the difference is that every time you multiply I times I, you get I squared, and I squared is now back to being a real number, so you'll need to do that in your simplification. To begin, let's distribute 4i times negative 6 plus I. Negative 24i plus 4i squared. Negative 24i is an imaginary number, but 4i squared is not actually imaginary. Yes, I see there's an I there, but what is I squared? I squared is negative 1, so plug that in. This simplifies to be negative 24i minus 4, but they asked us to write it in standard form, so we need to write the real before the imaginary. For part B, I have the product of 3 things, 2 terms and a group. Let's multiply the terms in front first and then distribute that result into the group. 2i times 4i is 8i squared. But I squared is a real number. It's negative 1. So let's replace it. Now distribute negative 8 into 3 minus I. Is it in standard form? Yes. When we multiply 2 complex numbers that have a real part and an imaginary part, it's similar to when we multiplied 2 binomials. We can use the box method or double distribute. I'll show you one of each. The real part and the imaginary part of the first complex number need to be multiplied by both pieces in the second complex number. Continue distributing. Keep in mind that anytime you have I to the power of 2, you're back to real numbers. So go ahead and replace I squared with negative 1, and then combine the terms that have imaginary parts, 63i and 8i. Now combine your real parts, and we'll write it in standard form with the real part before the imaginary. You could also use the box method. I'll put one complex number as the columns, so 2 would be column 1, and positive 5i would be column 2, and then the next complex number as the rows, so 4 and negative 6i. Then we'll multiply row by column. So we can replace I squared with a -1 and then combine the imaginary parts. So we can replace I squared with -1, and that will make this term a real number, and combine it with the other real number. Also combine your imaginary numbers together. And our result is another complex number. Since I is a root, it cannot be left in the denominator. To simplify an expression with a root in the denominator, we must multiply by the conjugate. The conjugate of a plus root b would be a minus root b. As far as complex conjugates go, or the conjugate of a complex number, the conjugate of a plus bi would be a minus bi. Remember, you change the sign of the imaginary part, or you change the sign of the radical part when it comes to conjugates. So try it out. Pause this video, find the conjugates, and then press play to check. And here are your conjugates. To simplify each rational expression, multiply by the conjugate of the denominator. If you're going to multiply an expression, though, you cannot multiply an expression without completely changing and ruining the problem, unless you're multiplying by 1. Multiplying by 1 doesn't change an expression. Multiplying by 1 doesn't change an expression. It just gives you an equivalent expression. So we can multiply by 1, or we can multiply by a special form of the number 1. The conjugate of this denominator is 4 minus 6i. And I want to multiply this denominator by its conjugate. But if I multiply the denominator, I also have to multiply the numerator, so that I'm truly only multiplying this expression by 1, a special form of the number 1. Distribute -3 into the numerator, and then multiply these complex conjugates. But I'm not quite done, because there is a number that goes into all 3 of these numbers, a common factor. Go ahead and factor out 2 from the numerator and the denominator so you can reduce. Two over 2 is 1. Here is our answer. We should not have a negative in the denominator. So if you have a negative in the denominator, you need to distribute it back into the numerator, or write it in front of the fraction bar. I want you to try the second one on your own. Remember, you multiply by the complex conjugate's special form of the number 1. Press play when you're ready to check your answer. Oh, look, I have another common factor. Go ahead and reduce. And we have our answer.